This video will be about writing and ordering decimals. When I think about decimals, I think about money and coins specifically. So if you see here, we've got different values of coins. Now let's look. When we think about decimals, let's start with our old place value chart. So we remember that the ones are on the far right. So let's say if you just had 6 ones, for example, it's like $6, you'd put it here. If you had $16, we'd know that you have 1 10 and 6 ones. That's why we would write it like this. Let's say we had $9,016. We would write it like this, and you'd put zeros in here to mark the place. So in this case, there would be no hundreds, no thousands, etc. Now, let's go to the next idea here. So if we've got 485, we could write it like this, 485. Then if we've got 7,485,000. If you don't remember this, you can pause and see if you can give yourself a little bit of a refresher. Let's go on to the next idea. If you've got writing and ordering decimals, we've got 25 cents here. So you could just write it like this, 25 with the C symbol right here. You could write 10 cents like this, 5 cents, not to be confused with $5, right? Or 1 cent. A penny, this little 1 cent used to be something that we'd have. We don't really have it much anymore. But let's look and see how we could write these as decimals. If you've got something like this, how many ones do you have? How many whole numbers do you have when you have just a penny? Well, you have 0. And in this case, you would write this like this, because you have 1/100th of a dollar. So if you had 1 cent and you multiplied it by 100, you'd have 1 whole dollar. So that's why we have the 1 in the 100th column here. If we're looking at something like 10 cents, again, we have 0 ones and we've got our decimal place. We have 1/10. It's 1/10 of a dollar. So if you multiply 10 cents times 10, that's $1. We can put zeros in these columns, but we also don't have to. This means the exact same thing as this and the same as this. Now moving on to look at something like 25 cents. A decimal will have a 0 in your the ones place unless we have a whole number as well as decimal as well. So you've got 2 tenths, 5 100ths, and then remember all of these could be zeros, or you could leave them blank. You could leave it just like this. It'll be the exact same thing. Now we've got 25 cents, so 0.25 plus 0.01 cent. So if we add these all up here, 5 plus 1 is 6, 2 plus 0 is 2, 0 plus 0 is 0. So you've got 0, we don't have any whole, we don't have a dollar or more. We have a 2 and a 6. That's how you write your numbers. Let's look at something like this. We have $1. That's a way that you could write this, right? Because we have 1 whole dollar. We have 25 cents. Put a 0 in here to mark the place. You don't have to, but it's easier to have to line up your numbers. And we just may do our addition. If you notice here as well, when we're doing this, we just line up all of our decimal places in the same spot so that we can add. So now you've got $1.25, which makes sense. If you had $1 plus 25 cents, it's $1. When we're thinking about ordering decimals, it's always nice to think about things in whole numbers first. So for example, if I asked you which number is greater, 1 or 7? Well, maybe you just say 7 is bigger, but how do you know? So if you were to plot those on a number line, 1 and 7, with 0 being over here, the 7 is furthest from the number line, or further than 1, so we know that the 7 is larger. So we would do something like this. It's something you learned before. Now let's apply that with using decimals. Let's go over to the next slide. So if you've got, what's larger, 0.21 or 0.3 or 0.30? Well, if we're to plot them, actually let's not use that number. Let's use something different. Let's use what's bigger, 0.24. So if we're looking here, this number right here would be where our 0.20 is, I think. Let's just check. What are the spaces between each of these lines? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So what would be what do each of these lines represent? Let's look. Let's try and check. So is this 0.22, 23, 24, 25, 26, 27, 28, 29, 30? Perfect. So now I know what all of these would be. So I could put 0.22 here, and I can label the next one as 0.23. I could keep going. But if I'm trying to plot 0.21 and 0.24, which we know is right here, which one is larger? The one that's further along on the number line is larger. So in this case, that would be 0.24, so we would put a symbol like this. So that's the way that you would do that. Let's look at something else. So so this number line, let's say you're given something like this, and the question is, what's larger? 0.84 or 0.8? Okay, well, we need to figure out what each of these lines represent. So sometimes it's just 1, sometimes it's 2, 5, 10. We know because this is 0.81 on the far left and 0.9 on the far right, probably each of these represents 1, but let's try and figure it out. So 0.81, the next one 0.82, 83, 84, 85, 86, 87, 88, 89, 9.0, that works out. So what would this one be? Pause your video, think about it. It would be 0.91. And this one would be one value less, so 0.8 or 0.80. They mean the same thing. I'm going to take the 0 off just because you can. So our question is, this is back to our question over here. What is larger, 0.84 or 0.8? Let's plot both of them on the number line and see. So we've got 0.81, 0 and 0.8. This one is 0.82. This one's 0.83, 0.84. Okay, so here are our two numbers. We have 0.8 and 0.84. 0.84 is further along on the number line, so it's larger.